In this video, we're going to be talking about misleading graphs and statistics. So again, we've been kind of concentrating in this chapter about the different types of graphs and how to draw them, how to read them, how to interpret them. But we've kind of just always assumed that the graphs we were looking at were valid or good graphs. But there are times that you need to check out the graphs to make sure that what's being represented is not in some way trying to mislead you. You know, a lot of times advertisers make their product look better than it really is so that you'll buy it. Well, that can happen with graphs and statistics as well. So here's some of the things you kind of want to look out for in a graph. Graphs can be misleading for many reasons. Here's some. There are, let's see, there's no title. All right, so there's really not, all the information hasn't been given to you. It may look good, but you may not know really what the sample is all about. Okay, so the scale does not include 0. This could be a problem because you don't know maybe where the numbers started. All right, so they may look better than they are supposed to. Okay, there could be no labels on one of the axes or both of the axes. So they're not really, again, giving you all the information. Fourth way is that the intervals on the scale are not equal. All right, and so that may make your graph look better, and maybe show a better, like a sharper increase or decrease depending on what you're trying to represent. All right, so look to make sure the intervals are all the same. And then the last type is when the size of the graphics misrepresent the data. All right, so they may be drawing something really big to make it look like it's really large, and then something, or maybe on the other hand, they may be making it look really small so that you think, oh, this is going to be great. It's going to fit in my, wherever. Okay, so let's just look at some graphs and see how we can apply this. The line graphs below show the total hours Solomon spent doing his chores 1 month. Which graph would be best to use to convince his parents he deserves a raise in his allowance? Explain. All right, so we can see both of these have a title, Solomon's Weekly Chores. They both have their axis labeled, and this is total hours, this is the week, right? So the intervals look like they're all the same. This is going up by 1, this is going up by 2s. But if you just look at the graphs, if you're trying to convince your parents that you do a lot of work around the house and that you deserve a raise, it looks like in graph A that, man, he is doing a lot of chores. Look how high that graph goes. But if I compare it to this one starts at 0 and ends at 8. This one starts at 0 and ends at 8 also. But do you see how the difference in intervals, made a big difference? Because he used a smaller interval here, it looked like his line went a lot higher than when he did it here. All right, so he should use graph A because it's going to make his total hours seem much larger. All right, so let's continue. In exercises 1 and 2, we're going to use these graphs. It shows a company's profits over a 4-month period. So again, we're going to look for a title. They both say company profits, so that's good. And they both have their axis labeled. Okay, so this is profits, this is profits. These both have months. So both of the graphs are labeled, but if you might notice on graph A, they didn't tell us the numbers that go with the profits. So we really don't have all the information we need to have in order to know really what this graph is saying. Okay, but it looks pretty good because the profits are low here, but man, they're really high here. Okay, same thing here. They were low here. They got higher, but now there's a number attached to that. That gives a little more information. All right, so which graph would be best to use to convince potential investors? Investor, someone you want to put money into your company. So what could we use to convince them to invest in this company? Well, I'm going to use A because it looks like, man, I'm doing really good. All right, so why might the graph be misleading? There is no, okay, so right here we need to talk about this. There's no vertical. Remember, vertical's up and down. Scale. Okay, they didn't include the numbers. And again, there may be more than one reason, or you may have a different way of saying this, but as long as you can justify your answer, then that's fine. All right, so if we turn this over, on the back it says, which graph could be used to indicate a greater increase in yearly lunch prices? Explain. All right, so we have two different types of graph. In the first one, there's a bar graph. It's got lunch prices. I can see that my bar graph's been labeled, so that's good. I've got the years here and the prices here. Same thing here, I've got year and prices. So they've labeled everything. The difference is in the size of the graphics. So here the bar graph looks like it just went up a little bit each year, and really it did. It went from $3.75 to $4.50. That's 75 cents difference. So that's not, a huge increase. But if I look at the pictures here, I have this tiny sandwich here. And then over here, I have this huge sandwich. It's at least twice as big, if not 3 times as big. Well, the price didn't increase 3 times. Okay, it didn't go from $3.75 to $12. It only went up 75 cents. So they are making this look like there's been this huge increase in lunch prices. All right, so if I'm trying to show a greater increase, then I'm going to choose the sandwiches, because the ratio of the size of the sandwich or sandwiches is not proportional. Love that word, not proportional to the cost. Okay, so if I compare the size of the sandwich to the increase in the cost, they don't match. All right, for exercises 4 and 6, it says use the table that shows the miles of shoreline for 5 states. So again, I'm going to look at this table. Miles of shoreline means how many miles are on the beach, basically. We've got 5 states here, and the lengths, so in miles, how much of their state is on the next to the ocean, basically. All right, so we've looked at graphs. Now we're going to look at statistics, because they can also misrepresent data. So determine the mean, median, and mode of the data. So first thing I'm going to do is just find out what each of these is. So to find the mean, remember I'm finding the average, so I have to add up these numbers here. 5 plus 0 is 5, plus 6 is 11, plus 5 is 16, plus 9 is 25, carrier 2. Okay, 2 plus 1 is 3, plus 9 is 12, plus 2 is 14, plus 7 is 21, plus 8 is 29, carrier 2. 2 plus 3 is 5, plus 1 is 6, plus 3 is 9. And then 3 plus 3 is 6, plus 3 is 9, plus 3 is 12. Okay, so I get 12,995, but I still need to divide. So there are 1, 2, 3, 4, 5 states. I need to divide by 5. 5 will go into 12 twice. When I subtract, I get 2. Bring down the 9. 5 will go into 29 5 times. Subtract 25. Bring down the 9. 5 will go into 49 9 times. Subtract 45. And bring down the last 5. 5 will go into 45 9 times. All right, so my mean is 2,599. My median, remember, is the middle number, but first they have to be in order, least to greatest, so I need to take care of that. And the smallest one is 89. And then I have, what's next? 3,026. And then 3,190. 3,015 and 3,375. All right, so if I find the middle one, let's first and last. The middle one's going to be 3,190, and then the mode would be the most common. If I look at the numbers, none of them repeat, so really there's no mode. Okay, so I've answered that question. Number 5 says, which measure of center is misleading in describing the miles of shoreline for the states? Explain. All right, so the mean was 2,599. If I look at the actual numbers of shoreline, 2,599 seems kind of low, because all of these are in the 3,000s, except for this one. So what really happened? Why is my mean so much lower? Well, this is an outlier. It's making all of these numbers appear much lower because this one was so low. But in general, most of the states have quite a bit of shoreline. And the median is 3,190, which seems much closer to 4 of the states. The mode doesn't really tell me anything. So I would say the most misleading one is the mean And that's because it's going to make the shoreline, the amount of shoreline, appear much smaller. So all but one state have over 3,000 miles of shoreline. The outlier makes the mean lower than what is typical. Okay, and then number 6 says, which measure of center most accurately describes the data? So in comparison, the median is much closer to what most of the shoreline is. So it's going to be my best representation. The median is closer to the majority of states represented. So it is most accurate. Remember, this is consistent with symmetric and non-symmetrical graphs. So we've said when we look at a symmetrical graph, the mean is a good representation of the center, but when it's non-symmetrical, like in this case, this is not going to be symmetrical because of this really small think about a bar graph. These are all going to be about the same height. This one's going to be really low, so that can't be symmetrical. And so remember, it's better to go with the median when you have a non-symmetric graph, which we can tell from the numbers that we just looked at that that's true in this case as well. All right, so misleading graphs and statistics, just be aware that there are people out there, right, that want to sell you things, and so you need to check out what they're showing you, especially as you get older and you tend to want to put your money in things, investments. Check out what these people are truly saying, seeing if they're really being honest with the way they're presenting the information they're showing you. All right, see you later.